All right, we are talking about the average value of a function. And what is the average value? Well, the average value represents here the average height of rectangles that we can inscribe over a function interval. And so let's say we're looking at the interval from A to B. It would be the average height of all of the rectangles that we could draw that would overlap that function, if you will, to compute the area, the average height. Okay, so when we're looking at the function, it is basically a play on the fundamental theorem of calculus right here. All right, what we do is we divide it by the distance or the width of the interval. So basically, think about it. If you have the area, and remember when we do the fundamental theorem, we're getting the area under the curve. Remember that area equals length times width. Well, in this case, we are doing area equals the height times the width. So if we divide by the width, which is b minus a, let's just do the simple math here, we end up with the height. So this would be the average height. Okay, that's what we're computing here. All right, so there's nothing to it. Very simple, very intuitive if you think about it this way. So let's go ahead and take a look at a couple of examples here. So we are given two functions. We'll look at number 9 here first. Find the average value of the integral. So what we first have to do is we have to integrate it. 4x to the 4th dx from -3 to 3, and I'm going to take the average value, so 1 over b minus a. So 1 over b minus a, 3 minus -3. All right, 3 minus -3. We're going to add that, so we end up getting 1/6. All right, and I'll write that out front, but now I'm going to take the antiderivative. That is to say 4x to the 5th power, because remember you add 1 and then divide it by the 5th power. And then we're going to evaluate it using the fundamental theorem from -3 to 3. Okay? And nothing to it there. All right, so what does this look like? It is 1/6 of 4 to the 3rd power. I'm sorry, 4 times 3 to the 5th power divided by 5. Minus 4 times -3 to the 5th power divided by 5. All right, something that looks a lot like that. And I'm going to continue here. I'm going to go ahead and do the evaluation for you. 3 to the 5th times 4 is, 3 to the 5th is 243 times 4. There we go. That's what I meant to say. Minus, and then in this case, it's going to be a negative 243 times 4 divided by 5, and the minus makes for plus. Okay, so we end up with a positive in the inside. On the inside, you do that simple calculation. You can do it on your calculator if you will. We get 1/6 of 1944 divided by 5, and then when you multiply those two fractions, you get something like 324 over 5. All right, and that right there represents the average height of all of the rectangles from A to B if we were to overlay those rectangles on the function, on the graph of the function rather. All right, so that's one good example down. Let's take a look at one last one here. All right, we are looking here at this one we call number 10, and we are going to integrate it. Integrate x squared minus 2x plus 2 dx, of course, from 0 to 2. We're going to say 1 over 2 minus 0. So we right off the bat write 1/2, and we're going to say, okay, x cubed over 3 minus 2x squared over 2 plus 2x, evaluated from 0 to 2. The 0 makes this one really nice because there's actually nothing to plug in if you think about it. But we can kind of clean this up just a little bit. We get x cubed over 3 minus x squared plus 2x. That's just a little bit that we had to clean up from 0 to 2. And we don't actually have to plug in 0 because all of these things inside have an x. They're all going to be 0 in effect. So basically our answer boils down to 1/2 of 2 to the third power divided by 3 minus 2 to the second power plus 2 times 2. All right, so we should see there that the inside ends up being a 4 and a -4, or -4 and 4, I should say. 1/2. This is 8 over 3 minus 4 plus 4. Again, that's what I was getting at. They cancel. And we end up with 1/2 of 8/3, which ends up being, if you reduce it, this becomes a 1, this becomes a 4, ends up giving us 4/3 as our final answer. So the average height of these rectangles here would be 4/3 units. All right, so nothing to it. Again, this concept of average value, it just makes so much sense when you think about it geometrically, that's what's going on. You're getting the average height, and that's this value, this number, whatever this y value is there, that is what we're solving for, the height of those rectangles. All right, the average height anyways. So I hope that these examples were good, they were helpful, and as always, like and subscribe.